We're going to work on tonight.
Law of cosines, I believe.
Okay.
Sorry, I'm just getting organized here.
No, that's okay. I'm trying to find my program for my tablet. Oh, there it is. So what does the law of cosines say about this triangle?
I have it written down here somewhere. I couldn't tell you from memory.
Well, let's work on it from memory. It's very similar to the Pythagorean theorem.
Okay.
Okay, so I could say c squared equals a squared plus b squared. That's the start of it.
Yeah.
But then you have to subtract 2 times AB cosine of angle C.
All right.
And there's 3 different laws of cosines for any triangle. In other words, I can also say that A squared equals the other 2 sides squared minus 2BC cosine of A. Notice the pattern. And finally, if I want to solve for side B, B squared equals A squared plus C squared minus 2AC cosine B. They all have exactly the same pattern. You're always taking the cosine of the angle that's opposite the side you're trying to solve for. So, regardless of the triangle, you can use one of these 3 formulas.
Okay.
Now, where do we use the law of cosines? Only 2 places.
Was it side, side, side?
That's one of them.
And side, side angle?
Side, angle, side.
Okay.
And think
What's
about
the difference between those? I've never really understood that.
Well, let's think about this. In order to use the law of sines, which is what we end up having to use on every triangle, even though some of them we have to start out with the law of cosines, you still always have to use the law of sines. But in order to use the law of sines, you have to have an angle and its opposite side. So if I had a triangle like this, I can solve this using the law of sines because I have the 30-degree angle and I know its opposite side is 8. So once I have that a relationship established in a triangle, I can solve the entire triangle based on that. Because the law of sines says that that has to be the same for any angle and opposite side, that ratio. Well, in this situation here, we don't have an angle at all. And in this situation here, we have one angle, say that's 30 degrees, but we don't have its opposite side. So in neither of these 2 situations can we start out using the law of sines. But we can use the law of cosines in both of them. And the law of cosines will tell us one of these angles, whichever one we want to start with. Once we solve for one of these angles, then we finish the triangle by using the law of sines.
Okay.
Same here. In other words, in this case, that's side A. Well, if I go to solve for side A, I know that this applies. Well, I know B, I know C, and I know the cosine of this angle. So everything on the right side of the equation is known, and I can solve for side A. Again, once I solve for side A, Now I have that fixed relationship for that triangle because I know the angle and I know its opposite side. Now I can solve the rest of the triangle using the law of sines. And that's really it in a nutshell. The law of sines is the law of cosines is easier than the law of sines because, for one thing, you never have the ambiguous case. The law of sines can be tough because of that ambiguous case of the law of sines. But the law of cosines is always perfectly clear-cut. It's never ambiguous. Okay. So, do you have some problems that you want to do?
Yeah.
Okay. What's the first one?
Yeah, the first one is a triangle with, it gives the three sides.
Okay.
24, 27, and 19.
Okay. So we can draw a picture, but don't really need to in this case. So all I need to do is solve for one of these angles. Okay? So give me one of the law, and I can pick whichever angle I want. There's no advantage to picking one over another. So give me the law of cosines that applies to this triangle. Hold on a moment. This has to be A, this has to be B, and this has to be C. Okay.
So be like 19 squared equals 24 squared plus 7 squared minus 2 times 24 times 27 cosine C.
There's only one unknown in that equation. And that's C.
Okay.
Okay? So we'll be able to solve for it. So let's see. Do you have a calculator?
Yeah.
Let's put in some numbers here. What's 19 squared?
That is 361.
And 24 squared?
576.
And 27 squared?
729.
And what is this number?
1,296.
Okay. It's the first. Add these two for me. Let's see. That's got to be 1305, I think. Right? Or was it 04?
1,305. You got it.
Okay. So subtract that number from both sides. What do you get on the left?
Negative 944.
Next step.
Divide by negative 1,296.
What do you get over on the left?
.728. Oh wait, well we need to do the inverse cosine of that.
Yes.
Okay.
Wow, all of a sudden my pen stopped working. What was the number?
It's .728. That.
hold on. My computer has been acting up today. Wow. Hold on, let me try something. Something I've never tried when this has happened. And that's unplugging my tablet. Just to see if that is the problem. I don't think so. It didn't seem to solve anything. Oh boy, let me close this, see if that helps. Yeah, that might help. Okay. Well, let me replug my tablet back in. I've been dealing with this problem for a long time, and I've never had any fix for it other than to reboot my computer. But maybe I just figured out how to do it, which is just unplug my tablet and plug it back in. Let me see here if I can still open this thing. Alright, so we have cosine of C equals 0.7, what was the number?
728.
So C is equal to the inverse cosine of that?
Yeah, and that is 43.25
degrees. Now, what if we would have gotten this as cosine of C? What would we have done?
Would that work?
No, that means that it's an impossible triangle.
Oh.
In other words, because the cosine, the range on the cosine has to be from -1 to 1. Can never be greater than 1, can never be less than -1. So when you're using the law of cosines or sines to solve a triangle and you get to where the sine or cosine of an angle is outside the range, that means we didn't have a solvable triangle. Well, in this case, it was okay because it was 0.78, and so we were fine. But watch for that, because sometimes they'll give you dimensions that are an impossible triangle. You know, if they'd have given you dimensions of, say, 7, 8, and 16. Let's say they gave you a triangle that was supposedly had those lengths. Well, that's an impossible triangle. Remember the rule in geometry that says any side has to be less than the sum of the other two? Well, 16 is not less than 7 plus 8. So this can't be a triangle. And if I gave you this and you tried solving it using the law of cosines, you would end up with cosine of one of these angles is greater than 1. Okay? So that's your clue to look for. Whenever you see this is greater than 1, you know that you've been given an impossible triangle. Well, this triangle was possible. Not only that, now we know, let's see, this was 27, 24, 19.
Yeah.
And we solved for this angle, so that's 43.25 degrees. Well, now it's easy, because now we have an angle and its opposite side, so we can finish and solve for any other angle, which is either this one or this one, using the law of sines. So what would the next step be? Let's see, this was C, this was A, and this was B, I believe. So how do I finish solving this triangle?
So we would do sine of 43.25 over 19 equals sine of A over 24.
So sine of A equals 24 times that. What is that number on the left side?
So do I just multiply the top and divide it by 19 then?
Yeah, or yeah, you could take the sine of this number, multiply it by 24, divide by 19. You can do that in most any order you want.
That gives us 0.86.
Okay, again, we're good because we're less than 1. If this was greater than 1, we'd have problems. Although we probably would have already discovered what those problems are by now. But okay, so angle A is what?
59.9.
Now, to get the final piece, in other words, every triangle that you solve, you have to come up with 6 pieces of information, all 3 sides, all 3 angles. Well, we could use the law of sines again to get that angle, but there's a much easier way. What is it?
Not sure.
Subtract it. Just the total has to be 180. So add these 2 angles, subtract from 180. What do you get for this? Should be 70 something.
76.85.
Okay, so there we used 3 different principles. We used the law of cosines to find one of the angles, and we used the law of sines to find a second angle, and then we used the fact that there's 180 degrees in a triangle to find the third angle. And that's exactly the pattern you're going to use every single time you solve a triangle that's side, side, side. You have one that's side angle side?
Yeah. So, side A is 14. Side B is 12.
I'll make this B this time.
And angle C is 42.
Okay. Again, we have no angle opposite side relationship to draw upon. So we have to use the law of cosines. Which side do we need to solve for first?
Side C.
Okay. So C squared equals what?
C squared equals 14 squared plus 12 squared minus 2 times 14 times 12 cosine C.
Cosine of 42 degrees.
Yeah.
Again, there's only one unknown in this equation, and that's C. So C is going to be the square root of that number.
Okay.
Okay? Once you come up, if you want to take the time to do it, go ahead. We'll come up with C. Then we have a side opposite angle relationship, and we finish it using the law of sines. If you want to come up with that number, let's go ahead and finish this out.
So that gives us 9.5.
Okay. Now what?
Now we would do sine of 42 over 9.5 equals sine of A over 14.
So sine of A equals 14 times that. Again, this will tell us if this is a possible triangle or not. I'm not sure at what step the impossible comes out. I don't know if it always comes out when you do the law of cosines, or sometimes you have to wait until you get to the law of sines before you discover it's impossible. This one's clearly going to be possible, but Same thing.
This one comes to be 9/8. Oh wait, that's the inverse. Okay, so I'll do the inverse sine of 0.98.
Okay.
So when I did 14 sine 42 over 9.5, that gave us 0.98. So
Okay. The inverse of that, 80-something degrees.
yeah, 80.43.
And the last angle?
Is 57.56.
Okay. So same thing. Start with the law of cosines, use the law of sines once, and figure out the last angle by subtracting from 180. Would you say 57.57? Okay. That's the only two cases you have to use the law of cosines. Is when you have side, 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 or side, angle, side. Every other triangle you would use the law of sines completely.
Okay.
Got another one?
The next few problems, it doesn't have picture changes with phase, so
Okay.
pretty much just,
They just give you 3 pieces of information?
yeah.
Okay.
So angle B is 35 degrees. Side A is 43. And side C is 19.
Okay.
So we would do B squared equals 43 squared plus 19 squared minus 2 times 43 times 19 cosine 35.
So B is the square root of all of that. Wow, I am happy that I found a solution to that problem. That's going to be amazing. That's going to change my life. My computer difficulties were really getting to be annoying.
Oh, with the tablet?
Yeah, I mean, about 1 in 5 sessions, I end up having to reboot in the middle of the session and resending another meeting ID number to finish the session. So if I can solve that problem by merely unplugging and plugging my tablet back in, that's huge. And I've dealt with that problem for at least a year, never knowing how to solve it. So.
Okay, that gives us 29.52.
Okay. Does that look odd?
Yeah.
A little bit, doesn't it? Why? Because we know that every triangle, the smallest angle is opposite the smallest side. Well, if that's going to be true with this triangle, angle C is going to have to be awfully small. Not that that's impossible. It could be. But right off the get-go, it looks a little strange. Let's see.
Adding the sides together, and
If it's an impossible triangle, we'll find out in the next step.
Okay. All right. So now we would do sine of 35 over 29.52 equals
Let's figure angle C because that's the one I'm concerned with.
Okay. That would be sine C over 19.
Okay. So, what's that equal to?
Sine C equals 0.369.
Okay, that's within its range. What's angle C equal to?
21.66.
All right, now things make more sense. And what's angle A equal to?
Minus 21. 123.34.
Okay. So I was a little hasty to be judging it based on the initial fact that that came out to be 29.
Yeah.
But you kind of look for stuff like that. The biggest thing you want to look for is when you get the sine or cosine equal to some number greater than 1. That's when you know you have an impossible triangle. Okay? What else?
Next is side A equals 1, side B equals 5, and side C equals 4.
Ha! Notice this is an impossible triangle. You see why?
I can't remember, but if you say,
Yeah, any side of a triangle has to be less than the sum of the other two sides. Think about it. If I make side B, B5, well, the shortest distance between 2 points is a straight line, so there's no way that if I make a triangle like this, the sum of those other two sides has to be greater than 5, correct?
yeah.
Just based on the fact that the shortest distance between 2 points is a straight line. And that's a crooked line. Well, that can't be. I can't have 5 being equal to the sum of the other two sides. We wouldn't have a triangle, we would have a straight line. That's all we would have. Okay? So, and this fails on all three sides. In other words, the rule is any side has to be less than the sum of the other two, or the opposite. By that I mean or greater than the difference of the other two. Well, 5 is not less than 1 plus 4, so it fails there. It is greater than 3, the difference of the other two, so it's okay there. But notice that side, and this has to apply to all three sides of the triangle, have to pass this law. Okay? Well, side A, 1, is not greater than the difference of the other two. The difference of B and C is 1, and A is not greater than 1. Can't be equal. It's got to be greater or less than. So, let's try to use the law of cosines. Let's say we don't notice that. Let's solve for one of the angles.
Okay.
Let's solve for angle B. You pick it at random. It doesn't matter which one.
So 5 squared equals 1 squared plus 4 squared minus 2 times 1 times 4, the cosine B.
Okay, did I do something wrong here? Let's see, 5 squared equals 1 squared, that's 1, plus 16 is 17, minus 8 cosine B. Okay, so right off the get-go, where is cosine equal to negative 1? Where's cosine equal to 1?
90 degrees.
No? Do this in your calculator, yeah, exactly. If you take the inverse cosine of minus 1, you'll get 0.
Okay.
Well, actually you won't. You'll get pi, 180 degrees. Either one is impossible. You can't have a triangle where an angle is 0 degrees, and you can't have a triangle where one of the angles is 180 degrees.
Okay.
So immediately you know that this is an impossible triangle.
Next one.
And it wouldn't have mattered which side we picked. All of them would have given us the impossible cosine of B.
All right. Okay, the next one, side A equals 9.8. Side B equals 12. And side C equals 23.
Can we tell right off the get-go if this is possible? Let's see. 9.8 has to be less than the sum of these two, which it is, and it has to be greater than the difference of those two, which it is not. Okay? So, by using that geometry rule, I can tell that this is not a possible triangle, but also let's use the law of cosines. This time I don't know that it matters which side we start from. I suspect we're going to find out it's impossible on the very first one that we try.
All right. So, should we just do like A then?
Sure, we'll start with the smallest number.
So, 9.8 squared equals 12 squared plus 26 squared. Okay, 9.8 squared is 96.04.
I don't know what 23 squared is.
529.
And 24 times 23 is what?
That is 552.
Okay, let's add these two, subtract from the left, and divide by minus. Always remember that that's always a minus sign there.
Okay.
Because it's the law of cosines. So you're always, the second to last step in solving the law of cosines is always dividing by that negative number. In this case, we're going to be dividing it into a negative number, so far so good. You don't like your cosine to come out to be a negative angle. I guess it's okay if it does, because cosine is negative in the second quadrant, so all that means is the angle would be somewhere between 90 and 180 degrees, which is okay. I mean, if it were a possible triangle, it'd be okay. We're going to discover it's impossible here. I'm just not sure at what step we're going to discover.
Okay, so that is 673.
Okay, and then subtract this.
That's negative 576 makes 986.
Okay, notice what happens when we go to divide by minus 552. That number is greater than 1.
Oh, yeah.
And that's all you need. You don't even need to do anything further. Once you get to this step right here, you're done.
Okay.
It's impossible. Okay? What else?
I think that's a good hold on a lot of cosines for now.
Yeah.
I actually got some extra credit problems today.
Okay.
One of them interested me a bit, but I couldn't figure out how to do it.
Okay. Let's take a look at it. Maybe I can help.
Yeah, I took a picture of it, so I'll just send you.
Okay.
It's a triangle thing.
Okay. Wow, I almost want my computer to go bad again so I can fix it, just to convince myself that unplugging and plugging fixes it. I know, that's terrible. But I would be so happy if I could find the solution for it. And it's really annoying. I don't know if it's ever happened when I've been in a session with you. Has it? Have I ever had to reboot in the middle? It seems to happen more with certain students. Makes me wonder if it has anything to do with their end. Which wouldn't really make sense. Almost has to be either in my computer or could be in GoToMeeting. But I suspect it has to do with my tablet. Oh, nice.
When I did it, it came up with x equaling 90 degrees, and application fell wrong.
Yeah, that doesn't look right, but you can't always tell. They're not always going to draw it to scale. And let's see what we have here. Geometry problems are always, you just kind of figure out everything you can figure out, and eventually you'll figure out x. So what's this angle right here?
That one is 50 degrees.
Okay. If that's 50, what's this one?
That'll be 180 minus 50, so 130.
Now what's this one up here?
30 degrees.
Let's look at this left triangle. What's this angle right here?
That'll be 180 minus 30 minus 10.
So that's 40?
Yeah.
We knew that because this has to be 130. Okay, so now, what do we know now? Thinking. This angle right here, was this problem given to you in the Law of Cosines context or just a triangle geometry problem?
It's just a geometry problem.
Okay. What am I not seeing here? Let's see. Well, we know this is 50. let's call this angle right here, for the time being, y. So what do we know? We know that y plus 20 plus x plus 30 has to equal 180, right? This right triangle, this triangle over here.
Yeah.
Okay, that's one equation. So we know y plus x equals 130. Now can we come up with another equation with x and y in it? Yeah, this triangle right here says that, in other words, this triangle right here says that x plus y plus 40 plus 10 has to equal 180. Doesn't help, does it? Just tells us x plus y equals 130 again.
When I was going out, I basically drew lines, like parallel lines along some of the other lines, and I kind of did the alternate interior and.
The problem is there's no parallel lines here.
Yeah, I kind of made my own.
Thinking, let's see, there's one other equation I can think of that involve x and y. Let's see what that is. In other words, we not only have triangles here, but we also have a quadrilateral. But I bet you that gives us the same thing. Y plus x equals 130. Because we're going to have 80 plus 80 plus 40 plus y plus x plus 30 equals 360. Yeah, that's not going to help. Or does it? No, that just gives us y plus x equals 130 again. This can't be that hard. It's not a law of sines or law of cosines problem because we have no sides at all. And if you have no side lengths, you can't use the law of cosines or the law of sines. In other words, if you have angle, 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 you can't solve it. However, no. Oh, I see what you did. Yeah, I don't think you can create any parallel lines here that help the solution any.
Well, I kind of, I tried to make like another triangle up in that upper
Oh,
section.
yeah. In fact, we know this angle up here. There you go. If this angle's 80 and this angle's 80, this angle's 20.
Oh, yeah.
And now, if this angle's 20 and this angle's 20, this whole angle has to be 140. So y plus z is 140. And this angle is 150 minus x. So we have y plus z equals 140. And then we have and then we have this other big triangle over here, which is 2010. So this angle here, we just solved it. That's 150. Ooh, hold it, we didn't just solve it. However, I think we're getting closer. I mean, you see why it's 150? Because this one's 10, this one's 20. So this angle, x plus this angle, x plus d equals 150. And z plus d equals 160. So if I subtract the two, I get z minus x equals 10. And I know that y plus x equals 130. We have one more equation that's independent that will allow us to solve this for, let's see, I've got x, y, and z. I hate geometry problems that I can't solve, because I can solve most of them. Let me think about this for another minute. Do we have similar triangles anywhere? I don't think so. 10, 20, and 150. 20. Yeah, we have a z plus y. Has to be 140. Okay, we got that here. Z plus y has to be 140. Z minus x has to be 10, and y plus x has to be 130. There's our three equations. Let's see if we can solve those three equations. Let me see. Let's see. We got y plus z equals 140. We have y plus x equals, what was that, 130? And our third equation is z minus x equals 10. Now that follows from those first two equations. If I merely subtract equation 2 from 1, I get z minus x equal 10. So that's not a third independent equation. Wow. No, I don't see it. Sometimes you just kind of have to see these. Usually the solution for these lies in filling in every single angle you can possibly figure out. And then you'll know. In other words, if we could fill in this angle and this angle, we'd know x. I'm convinced that the solution does lie in coming up with three equations and three unknowns. I just can't see how to do it. Did you have another extra credit, or is this the only one?
There's also it's on the left of that picture. I'm happy to head it in front. I can read it to you.
Okay. Go ahead, I'll take a quick look at it. I hate to give up on a problem, but I don't seem to be making much progress on that other one.
Yeah, it's fine. The other one is there's a cow tethered to a corner of a 10 by 10 foot barn.
Okay.
And a 100-foot rope.
The cow is tethered to the barn at the corner?
Yeah. And it wants to know what the maximum grazing area is. So how far could, like how much area could it cover? That 100-foot rope.
Okay. This is 10 by 10.
Yep.
Well, this can't be too hard. So at its lowest point, that's 100. At this point over here, that's 90. At this point over here, that's, whoops, excuse me. It can go up 90 there. And this side here is square root of 20. So it can reach a point over here that is 100 minus square root of 20. And it can clearly go 100 feet right there. So, can cover that area. 1/4 of a circle of radius 100. Can cover that area. 1/4 of a circle of radius 100. And it can cover that area. 1/4 of a circle of radius 100. And in fact, it can cover the area of a full circle radius 100 minus the area of the barn, which is 10 by 10. So we have 10,000 pi minus 100. That's the area that it can cover. I think that's right. In other words, if it's tethered right here and there was no barn, there was just a peg in the ground, then it could cover anywhere in the circle of radius 100, right?
Yeah.
Which would be 10,000 pi square feet. Well, this is exactly the same problem. Well, no, I guess it isn't. I guess it isn't, now that I think about it. In other words, when you're in this area up here, you can't actually go to this point right here because the rope would have to wrap around the building. It can't go through the middle of the barn. So this is the tough area here. We have to look at that different. However, it can definitely go 3/4 of the area of the circle. So 7,500 pi plus whatever these areas are. hard can that be to figure out? Let's erase everything here that we don't need. Okay. So in other words, when the cow gets to here, that's 90 feet. Now it's essentially tethered at this spot, right?
Yeah.
And it could go 90 feet. So that this distance here would be 80 from here to here, but it can clearly cover this whole area. In other words, a quarter circle of radius 90. So what is that? So we have 7,500 pi plus 1/4 90 squared pi. That's this area. And if it goes around the other side of the building, it would essentially be tethered there, and I would have the same quarter circle.
Yeah.
So it would be able to get to all this area also, which would be another quarter circle. So that would be same radius, so I should have two of these, so that's going to be 1/2 90 squared pi. So the answer should be this. I think. Let's see. This area right there is a quarter circle of radius 90. What area is left? Let's see. When the cow stretches the rope out to right there, it can go another 90, and then it can move in another quarter circle. And this area we've already covered with our 7,500 pi. So I think this is right. Do you have answers on this?
No, he didn't give us the answers.
I believe that's probably the answer. 7,500 pi plus 1/2 90 squared pi. Okay? And I didn't draw it such that I can draw this part up here, but I can't imagine that this part up here has to be symmetrical with this part right here, doesn't it? Because it doesn't really matter whether the cow goes around this side of the building or he goes up there. He's only going to have 90 feet of rope to operate with to get to this part of the area. And that's going to be a quarter circle, I believe. Unless there's some overlap here. There might be some overlap on these two quarter triangles. I bet there is. Fortunately, my thing has stopped work. No, there it goes. Okay. Yeah, in other words, when I look at my barn and I figure out, okay, this quarter circle here with the radius 90, and then this is going to give you a quarter circle also, like that, and there's some overlap there. So I'm not going to be able to add those two quarter circles together. I'm going to have to add them and then subtract out the overlap. And you can probably figure out what that sector radius is right there. That looks to me like, oh man, I'm not sure. That's a quarter circle that has radius 80. might have to take this and subtract out the overlap area. You know what I'm saying by why there should be an overlap there?
Yeah.
Okay. I'll let you take it from there. These are hard extra credit problems, but I think doable. If you draw a good picture of this, it should take care of the problem.
All right.
All right, Daniel. I'll talk to you next week.
Yeah, thanks.
All right, bye-bye.